Question 2, Part B. The mass m of a whale is modelled by m equals 36 minus 35.5 times e to the power of negative kt, where m is measured in tonnes, t is the age of the whale in years, and k is a positive constant. Part 1. Show that the rate of growth of the mass of the whale is given by the differential equation dm dt equals k times 36 minus m in brackets. Start by rearranging this equation to make 36 minus m the subject. Now this will become important a little bit later on. So starting with this equation, let's move the 36 over to the other side. So we get m minus 36 is equal to negative 35.5 times e to the power of negative kt. Now multiplying both sides by negative 1, effectively just swapping these two terms around, we get 36 minus m is equal to 35.5 times e to the power of negative kt. Let's call this equation number 1. Now let's consider dm dt. So going back to our original equation, differentiating m with respect to t. Now the 36 differentiated is equal to 0, so we discount that. So dm dt is equal to negative 35.5 times e to the power of negative kt multiplied by the derivative of the index, which is negative k. And that's because we need to use the chain rule. After all, it is a function of a function or a composite function. Now this negative k multiplies with the negative 35.5, so we end up with a positive value. So we end up with k times 35.5 times e to the power of negative kt. Now if we go back to our equation number 1, the 35.5 e to the power of negative kt can be replaced or substituted with 36 minus m. So we have dm dt is equal to k times 36 minus m in brackets as required. Part 2. When the whale is 10 years old, its mass is 20 tonnes. Find the value of k, correct to 3 decimal places. It's given that when t is equal to 10, m is equal to 20. So m of 10 is equal to 20. So substituting these two values into the original equation, we can then solve for k. Hence 20 is equal to 36 minus 35.5 times e to the power of negative 10k. Now we can rearrange this equation as so. So we have 35.5 times e to the power of negative 10k is equal to 36 minus 20. And 36 minus 20, of course, is 16. And we can divide that by 35.5 to make e to the power of negative 10k the subject. Now taking the natural logarithm of both sides, we get negative 10k is equal to ln of 16 divided by 35.5. Then dividing both sides of the equation by negative 10, we get k is equal to ln of 16 divided by 35.5 in brackets divided by negative 10. And that equals 0.07969 and so on, which rounds to approximately 0.080 correct to 3 decimal places. Part 3. According to this model, what is the limiting mass of the whale? The limiting mass is achieved as time approaches infinity. Now another way to look at it is, let's evaluate m of infinity. So that equals 36 minus 35 times e to the power of negative infinity. Now, as time approaches infinity, e to the power of negative infinity approaches 0. So this whole term here approaches 0. So m of infinity is equal to 36. Therefore, the limiting mass is 36 tonnes.